Welcome to another exciting video on this channel. Today we focus our discussion on how electricity reaches our home. In an age where we're surrounded by electrically powered devices, from the humble light bulb to the complex computer, electricity is a fundamental part of our lives. It's so integral that we often take it for granted, not giving a second thought about how it's generated and transmitted to our homes. Electricity is a fascinating phenomenon, making a long journey before it powers up our devices. This journey starts at the power plants, where electricity is generated. It is then transmitted through miles of power lines, reaching substations and eventually our homes and offices. But there's an unsung hero in this process, a device that plays a pivotal role in ensuring electricity gets to us safely and efficiently. They're called transformers, and they're crucial in the process of electricity transmission. To understand this better, we need to take a closer look at a key component in this process, the transformer. So, what exactly is a transformer? A question that sparks curiosity in many minds, and rightly so. A transformer is a device that plays a pivotal role in our electrical systems. It's like a gatekeeper, controlling and directing the flow of electricity. In essence, a transformer is designed to change the voltage of an electrical supply, either increasing it or decreasing it, depending on the needs of the system. This is achieved through a simple yet ingenious design, consisting primarily of two parts, the core and the windings. The core is usually made of iron, providing a path for the magnetic field. Wrapped around this core, you'll find the windings. These are coils of wire, the primary and the secondary, that carry the electrical current. The number of turns in these windings determines whether the transformer steps up or steps down the voltage. Now that we know what a transformer is, how does it work? The magic of a transformer lies in a simple yet powerful principle of physics. This principle is known as electromagnetic induction. Conceived by the illustrious scientist Michael Faraday in the 19th century, electromagnetic induction is the production of an electromotive force across an electrical conductor in a changing magnetic field. To understand this in the context of a transformer, we need to dive a little deeper. Let's picture a transformer as two coils of wire, a primary winding and a secondary winding, wrapped around a common iron core. When an alternating current, or AC, is applied to the primary winding, it creates a magnetic field around the coil. This magnetic field is not static, it's dynamic and changing. Why? Because the current that generates it is alternating, shifting direction back and forth, causing the magnetic field to expand and collapse in rhythm. As this magnetic field fluctuates, it sweeps across the secondary winding. Now, here's where Faraday's principle comes into play. The changing magnetic field induces a voltage in the secondary winding. This is electromagnetic induction in action. But there's a twist. The voltage induced in the secondary winding doesn't necessarily have to be the same as the voltage applied to the primary winding. The change in voltage between the primary and secondary windings depends on the number of turns in each coil. If the secondary winding has more turns than the primary, the output voltage will be greater, and vice versa. This is the fundamental mechanism by which a transformer works. It's an elegant dance of magnetic fields and electric currents, a testament to the beauty of physics. This dance allows a transformer to do something truly remarkable, change the voltage of electricity. It can step up a low voltage to a high one, or step down a high voltage to a low one, depending on the needs of the electrical circuit it serves. It's a bit like an electrical interpreter, translating the language of voltage to suit the conversation at hand. And that, dear listeners, is the magic of a transformer. This is how a transformer can change the voltage of electricity. Transformers are not all the same. They have different functions depending on their design. Now that we've established the basics of how a transformer works, let's dive a bit deeper into the two main types of transformers, the step-up and step-down transformers. The names of these transformers give away their main functions. A step-up transformer, unsurprisingly, steps up or increases the voltage, while a step-down transformer steps down or decreases the voltage. But how do they do this? Let's start with the step-up transformer. It has more turns on the secondary coil than on the primary coil. This means that when alternating current flows through the primary coil, it creates a magnetic field that induces a higher voltage in the secondary coil. In other words, it steps up the voltage from the input to the output. On the other hand, a step-down transformer has fewer turns on the secondary coil than on the primary coil. This arrangement allows it to reduce the voltage from the input to the output. When alternating current flows through the primary coil, it creates a magnetic field that induces a lower voltage in the secondary coil. But why do we need to increase or decrease voltage? Well, imagine you're transporting electricity over long distances. If you try to do this at a low voltage, you'll lose a lot of energy as heat due to resistance in the wires. That's where the step-up transformer comes in. It increases the voltage, allowing the electricity to be transmitted efficiently over long distances. And when that high voltage electricity reaches your home, it's too powerful for your appliances. Just imagine what would happen if you plugged your phone into a high voltage socket. That's where the step-down transformer comes in. It reduces the voltage to a level that's safe and usable for your home appliances. So in essence, transformers act as the gatekeepers of electricity. They increase voltage for efficient transmission and then decrease it for safe use. That's how transformers ensure we get the right voltage for our needs. Transformers play a critical role in the power grid. This is a statement that's as true as the sun rising in the east. But why is it so? Let's delve into the world of transformers and their role in the power grid. When we talk about the power grid, we're referring to an interconnected network for delivering electricity from producers to consumers. This grid includes generating stations, transmission lines, and distribution lines. The electricity produced at generating stations needs to travel a long distance to reach our homes, offices, and factories. But there's a catch. Transmitting power at the same voltage it's generated would result in a significant loss of energy due to resistance in the wires. This is where transformers come to the rescue. They transform the voltage levels to ensure efficient transmission of electricity. At the generating station, a type of transformer known as a step-up transformer increases the voltage level. The high voltage allows the electricity to be transmitted over long distances with minimal energy loss. Imagine a highway. High voltage transmission is like having fewer, larger vehicles carrying more people. It's more efficient than having many small vehicles each carrying fewer people. That's the principle at work when we step up the voltage for transmission. However, such high voltage levels are dangerous for domestic and commercial usage. So before this high voltage electricity enters our homes or offices, it needs to be stepped down. Here, another type of transformer, aptly named the step-down transformer, reduces the voltage to safer levels. In essence, transformers act like guardians of the power grid. They ensure electricity is transmitted efficiently and safely from the power stations to our doorsteps. They step up the voltage for long-distance transmission and step it down for safe usage. And there you have it. Transformers are not just chunks of metal and wires, they are an integral part of our modern life. Without transformers, we wouldn't be able to safely and efficiently deliver electricity to our homes. So, why should we care about transformers, you may ask? Well, let's delve into that. Transformers, these unsung heroes of the electrical world, are integral to the functioning of our modern society. They are the silent facilitators that power our lives, quite literally. Imagine a world without transformers. It would be a world devoid of the convenience of using your favorite electrical devices. The television you watch, the refrigerator that keeps your food fresh, the computer you work on, or even the phone you're holding right now. None of these would work as they do without transformers. In essence, a transformer does the crucial job of adjusting the voltage of electric power to the right levels needed by various appliances. From a high voltage power line to a low voltage light bulb, it's the transformer that makes the transition smooth and safe. In our homes, transformers are working round the clock, ensuring our devices get the right amount of power they need. They step down the high voltage from the power lines to a safer, usable voltage for our appliances. This not only makes our devices work efficiently, but also safeguards them from potential damage due to high voltage. Moreover, transformers are the backbone of our power grids. They ensure the efficient transmission of electricity over long distances. Without them, the power loss during transmission would be enormous. They make it feasible to transmit power from remote power plants to our homes and businesses, enabling us to light up our cities and drive our economies. But the role of transformers extends beyond our homes and cities. They are also key in industries, hospitals, data centers, and virtually everywhere where electricity is used. They are indispensable in the functioning of complex machinery, medical equipment, servers, and much more. Thank you for watching. Please subscribe to be the first to receive our next wonderful video. So, their importance can't be overstated. Transformers are the silent sentinels, the invisible force that keeps our world running smoothly. They are the unsung heroes that make our electrified lives possible. Next time you switch on a light or charge your phone, remember the humble transformer that makes it all possible.